Hello, everyone. Thank you very much for joining this RF loss band coverage and multi-radio challenges in the Thingy 91X. So this is a partner webinar with Ignion and Nordic, and we'll jump right into the first slide here. So today's host is me, Martin Lesund. I'm a technical product manager for cellular IoT. And I've been working with Nordic for about 8 years. And to me, from Ignion, we have Jose Luis Pina. He's a product development manager from Ignion. So he's an expert on the antenna side.
Hello, everyone. Yes, as Martin said, I'm Jose Luis Pina. I'm the product development manager at Ignion, and one of my main roles within the company is to provide technical support to our partners. So in this case, we have been working together since the very first release of the Thingy, all the way through to this new and improved version, the Thingy 91X. So today, representing Ignion, I will explain what the Ignion virtual antenna technology inside the Thingy 91X is all about and how it simplifies the design process for developers.
Perfect. So just a little bit of practicalities before we get started with the meat on this webinar. It will last around 45 minutes, the presentation, and we expect around 10 minutes of Q&A. So questions are encouraged. We have a question tab on the right-hand side, so you can put in all your questions there. Try to keep them relevant to today's topic, and we will answer all the questions that we have time for at the end of this webinar. The chat on the bottom right sidebar is not anonymous, so it should not be used for questions if you don't want to do that. If you have more questions related to Nordic related stuff, you can go on DevZone after this webinar, or you can send an email to Ignion. They will share the email address at the end. The recording of this webinar will also be available together with the presentation if you want to watch it again or you missed today's webinar, and that will be posted on webinars.nordicsemi.com. So first off, why Thingy 91X? Why did Nordic develop this product? So first off, we have a lot of customers using our modules. Sometimes it can be difficult to create proof of concept, especially if you aren't experienced with that. And also it takes a lot of time to make your custom applications hardware to make prototypes. So to kind of speed this up for our customers, we made a prototyping platform. The first one was the Thingy 91, where we had the nRF9160 cellular SIP module on board, which was the brain, and then a lot of sensors on the board, as well as a battery. That means that the customer could buy this device, create their application, just focus on the software side, on the embedded side, and also on the cloud side, and don't need to worry about ordering or making or designing any custom prototype designs before. So this would speed things very quickly, so they can get something out in the market and test it out in the field, basically. So that could be an asset tracker, a smart metering type application. They could use the Thingy 91. And kind of as an addition, we wanted to this device be a reference design. That means we provide the hardware files online, so customers can just copy and paste whatever they like from the design and use that for their own uses. So they can pick and choose what sensor they want to use and what SoCs they want to use on the device. However, when you shrink things up like we have done with the Thingy 91 and the Thingy 91X, this successor, things can be challenging with regards to the antennas, because the antennas is also one of the most important parts of a wireless device, especially for cellular. This impacts the quality of the communication, and also, of course, power consumption. So if you have done a bad antenna design, this could mean that you don't able to communicate with your device, or that the device would use a lot of power consumption and burn up the battery. So that's why we teamed up with Ignion, both for the Thingy 91 and Thingy 91X, because they are antenna experts and they have a lot of experience in this field. And we found that their antennas was the best and optimized for this design when we went to several vendors and we tested. So we are very happy with the relationship. And yeah, that's why we made the Thingy 91X. So in the Thingy 91X box, if you buy this device, you would see that this prototyping platform can be used globally. It communicates through the cellular technologies, LTM and NB-IoT, but it also has support for GNSS and also Wi-Fi locationing. We also have built-in sensors for monitoring environment and movement. And it also comes with easy expansions via connectors. So if you need any other peripherals connected to this device, we have this quick and Stemma QT standard supported. And as we want to make it as easy as possible for customers to get started, we have also added 2 SIM cards in this device. So they can open up, plug in the SIM card and turn the device on, and they can get started. And it's already flashed with a out-of-box firmware, which we call Hello NRF Cloud. And it's one of the most simplest onboarding experiences, at least in my view. You just scan the QR code on the device and you get directed to a website where this Thingy 91X device you just have turned on will connect to and then start to send data and location data. So you can already get started to test, and then you can go ahead and create your own applications and run that on the device. So now over to Jose Luis about the antennas themselves.
Thank you, Martin. So yes, just I want to give a bit of context for those who don't know who Ignion is or what the virtual antenna is. I would like to give you a short introduction. So virtual antenna basically is a non-resonant antenna technology developed and patented by Ignion, a company based in Barcelona, Spain, that allow us, with only 7 products in its portfolio, to cover all existing and even future wireless services within the frequency range from 400 MHz up to 10.6 GHz. The current Ignion products are called antenna boosters, which are non-resonant components. That's why we describe them as virtual. They are called antenna boosters because together with a matching network, they help to boost the ground plane, transforming it into the actual radiating element. So now that we are ready to start talking about the challenges we faced during the Thingy 91X design journey. So basically, as you already see and know, in today's interconnected world, devices are expected to communicate across multiple wireless services. For example, in tracking applications, global coverage requires cellular IoT, GNSS, and Wi-Fi, for example, what it means to have multiple antennas working together. This leads us to the first key challenge that we faced, that is the multi-radio coexistence. At the same time, technology pushes and pushes for smaller and more compact designs, creating a trade-off between limited board space and wideband coverage. So to achieve high performance across multiple bands in such a small form factors demands a smart antenna integrations. On the other hand, designers also need adaptable solutions without redesign loops, ensuring flexibility across different products or even same product dimensions redesign, enclosures, etc. This will be, in fact, the key to reduce the device time to market path. And finally, related to the market path, this one is influenced by the regulatory and performance compliance. So certification demands for TRP and TIS have become a a critical step, as they ensure the device meets required standards for total radiated and total isotropic sensitivity. That mainly this is essential for global deployment. In the end, finding the right balance between performance, flexibility, size, and compliance defines the main challenges in the modern wireless designs, as these were exactly the ones we faced during the Thingy 91X antenna integration. So, having said that, let's jump directly now to review more in detail the Thingy 91X. So I'm getting back the flow to Martin.
Thank you. So we'll just look at Thingy 91 versus Thingy 91X. So first, we released this Thingy 91 in 2019. It had two antennas on board, one Ignion antenna that basically shared LTM, NB-IoT, and also GNSS. But we also had a simple chip antenna here for Bluetooth. It also uses the NRF 9160 and the 52840, which worked as a board controller as well as a Bluetooth low energy device for gateway type applications. Then we learned there was some challenges with only having one antenna. We saw some not the best performance on GNSS and LTM and NB-IoT. So when we designed the Thingy 91X, we wanted to improve this as well as to update everything to be newer chipset, the NRF 9151 SIP module. We updated that. We also added on the 5340 SoC. We also added in a new PMIC, which we used for battery charging and as well for accurate fuel gauging, which is the NPM 1300. And we also, of course, added Wi-Fi locationing with our NRF 7002. Basically, this can scan for Wi-Fi access points outside and inside and give a pretty accurate location of your device. Sometimes even more accurate than GPS, depending on the area you are. So with the three antennas, we now have a LTM and NB-IoT antenna here, a GNSS antenna here, and then we have the Wi-Fi and Bluetooth low energy antenna here. So all of these are Ignion antennas, and what we saw by this change and the improvements helped with the Ignion. We improved the cellular efficiency around 100% on the different cellular bands. We also improved the GPS efficiency by around 75%. So all this would improve the battery lifetime of the device and the performance of the device. We also added on some expansion possibilities with this new Thingy 91X. So everything we learned from this project, we brought into here and did a much better an improved device. So I think this is one of the coolest devices that we have made. I may be a little bit biased, but it's a lot of cool things you can make with this. Now, a more detailed look on the boards themselves. I'm not going to go into details here. This is just for reference, so you can look at it yourself. But I just want to mention some small things here. We have the pressure, humidity, temperature, gas sensor on the backside. We also have a low power accelerometer, so you can know the location of the device if it's upside down or whatever location it is. And we also have a SIM socket here for regular plastic SIMs. And on the top side, we have the opportunity to solder on an eSIM that you can also use. And LEDs and programmable buttons as well. So I think we can go back to you, Jose.
Yeah, of course. So first of all, I have to say that I like very much the Thingy 91X design because it's a clear example of how to integrate multiple antennas in such a small device. No? So here, as we can see, we have the three different antenna boosters working together on the same platform. Starting at the top left, the DUM extent provides GNSS coverage and delivers omnidirectional radiation patterns, ensuring a fast time to first fix. In the center left, we find the nano extent, our dual band Wi-Fi and Bluetooth antenna booster, covering both 2.4 and 5 gigahertz bands. And despite its tiny footprint, it provides robust performance thanks to its central placement. And on the top right side, we have the Triome Extend that handles multiple band cellular connectivity for LTE-M, narrowband IoT, and DEC NR+ applications, spanning frequencies from 617 up to 2.2 gigahertz. So at this point, I'm pretty sure that some of you are wondering about how it's possible to cover the full cellular range with such a small PCB dimensions, right? So I have the key. I have the pleasure to present you the software-defined virtual antenna solution. We call it software-defined because you can control the antenna response through software, basically. And thanks to this solution, we solve the limited board space versus wideband coverage challenge that we discussed before. So in summary, this board showcases how the Ignion virtual antenna technology can achieve broadband performance and multi-radio coexistence, enabling reliable connectivity across cellular, GNSS, and short-range bands. Having said that, let's take a look at the software-defined virtual antenna solution architecture. So, as you can see, the architecture is divided by 3 clear stages. The stage number 1, there is a pre-switch matching network. The stage 2, there is the Corvo switch. And in the stage 3, there are 4 components and the Triome Extend antenna booster. And how does it work? Basically, this setup allows up to 65 states, enabling it to cover the entire current and future cellular frequency range. In practice, as in the case of the Thingy 91X, only 8 stages are typically enough to cover the full range, the full cellular range. So as long as you keep in your own designs the same design layout and same bill of materials as the Thingy 91X, you will be able to give cellular worldwide connectivity to your device. In fact, just mention that you can download directly all the hardware files of the Thingy 91X through the Nordic website. You have here in this slide the link. So having said that, here we have the corresponding Thingy 91X switch state lookup table and how the performance looks like once the module is programmed. As you can see, with only 8 states, the software-defined virtual antenna solution can cover the full cellular IoT range. Just to clarify, a switch state lookup table is basically a table that is linking a switch state with the corresponding working frequency range. In the end, the switch state lookup table is literally programmed into the module. So then the module itself knows exactly what to do to transmit or receive data in a specific frequency band. So at this point, I would like to emphasize 2 points. The first one is that the software-defined virtual antenna solution delivers a 3 dB performance improvement in the low frequency ranges compared to other passive antenna solutions of similar PCB size available on the market. That's a significant gain, especially at lower frequencies, which are usually the most challenging for small devices. This improvement translates directly into stronger signal strength, better coverage, and more reliable connectivity, even in every compact form factors. Additionally, when we talk about performance, a 3 dB increase it also means that the radiation system is more efficient, as Martin said at the beginning, and that directly impacts power consumption. So if the antenna system is more efficient, the device uses less power, which in turn helps the battery life of the device. And the second point is just mention that this solution supports frequencies up to 3 gigahertz, covering the full LTE range up to 2.69 gigahertz. So now I bet that some of you have in mind the following question. What if my design doesn't have the same PCB size as the Thingy 91X? So from Ignion, we invested a lot in developing the software-defined virtual antenna solution with one clear goal in mind: to make it as simple as possible to be integrated in a wireless service. So in response to the question, what if my design doesn't have the same PCB size as the Thingy 91X? Don't worry. At Ignion, we have developed a lookup table for each PCB design dimensions. So if your device has different dimensions than the Thingy 91X, all you need to do is to upload through software the corresponding lookup table to the module according to your PCB size. And that's it. So as you can see here in this slide, and as I mentioned before, even if the PCB dimensions change, you will always be able to configure the Nordic module using the corresponding Ignion switch state lookup table to cover the entire cellular range and provide cellular connectivity to your device in a very simple way. So that said, in order to preserve the performance in your device, the only thing you need to do is to follow our design guidelines, which are the following ones. On the one hand, regarding the virtual antenna boosters, first, to control the coupling between GNSS and cellular regions, keep a distance of 5 millimeters between both antennas. Second, keep the same clearance area dimensions as defined in the Thingy 91X. So this means that no copper layers around or underneath the antenna boosters. On the other hand, regarding the software-defined virtual antenna solution, keep the same path layout as the Thingy 91X. This includes keeping a 1 millimeter distance from the switch to the next ground plane layer underneath it. So we have talked about the theory. Now let's see it in action. I will pass it back to Martin so he can show how simple and easy it is to define a lookup table using the Nordic software. Wait a second, Martin. We cannot hear you. Are you mute? You are mute.
Yes, I am. So that's great. So we have a documentation page for the Hello NREF Cloud firmware, which is the out-of-box firmware we have for the Thingy 91X. And there we have a section where we call what we call antenna tuning. So that's available for you to look into. Basically, we write two methods to change this lookup table and changing the antennas. First off, the way to configure it directly in application. So basically changing the project conf file, and you can put in the different parameters. So if you just look at the code, this is the default configs in the Thingy 91X, which is the default lookup table parameters and numbers stated here. So basically, when you turn on the device, this AT command will send this to the modem and then basically set the antenna up for the best optimization for this size. And of course, we have these commands also documented for if you want to know all the details on what each of the commands do, what the different parameters and everything that can be changed. That's also located on our documentation page. So I'm not going to write this in the project conf file in the project environment. Today I will just show you how to do it with 80 commands, because that's a quick and easy way to just test it out. And to do that, we can use a tool from our tool, and it will turn on the device. So the device is USB, and turn it on. You're leveling. I have also the desktop application here. So if you are familiar with what we provide by tools, I can quickly go through it. We have a cellular monitor tool which you can actually use for tracing modem logs. Look into what actually happens in a modem, what IP packets are sent and received. A lot of extensive insight that you usually don't get. So this is a great tool. This can be used with your custom device and all of our development kits and prototyping platforms. Then we have the programmer application where you can program everything, flash it. And then we have the quick start, which is the out-of-box flashing and guiding firmware application, I mean. But I'm going to use the serial terminal to send 80 commands. And I can select the device, Nordic Thingy 91X. And when I press the button, I should start to, let me reconnect, start to see some boot up messages here. And here I can send 80 commands by starting with AT and then a command. I can check the mode, ATC fun, question mark, for example. But here is the part that we had, the AT command XMIP control, and all the different parameters you can change. And the only thing you need to do to change these parameters from one lookup table to another is just send this AT command, and you get OK. And then it's changed on the device. So if you, for example, have a larger PCB, you could change this to other parameters based on the lookup table from Ignion. So it's very quick and easy to just tinker around with the device and see what works and what doesn't with these 80 commands. And when you have figured out the correct settings for your size and everything, and when it's optimized, you write this in your application firmware. And again, all this is documented, and we also link towards the Ignion application note, where also these details on the antennas is documented. So all this is linked to from this web page. So I think that was quick and dirty how you can change this on the device. So back to you, Pina.
Thanks, Martin. I hope, yes, you did it very, very clear, and you showed to the audience how simple it is. So now let's move on to reviewing the measurement results. As we can see, on one hand, for the cellular IoT range, the Thingy 91X shows around 30% average antenna efficiency at the lower frequency bands, and an average of 58% at the higher ones, thanks to the three-extent antenna booster. For the GNSS part, the device achieves an average efficiency of 70%, enabled by the dual extent, and for Wi-Fi BLE, it reaches about 30% for BLE and around 48% for the higher Wi-Fi bands. On the other hand, regarding active measurements for the cellular IoT section, just to give you an idea of the TRP and TIS values the device reaches across low and high bands, we have for those lower bands, bands 12 and 13, it shows TRP levels above positive 13 dBm, while keeping TIS values below minus 96 dBm. For the higher cellular IoT bands, the device achieves TRP levels above positive 20 dBm and TIS values below minus 106 dBm. So it's important to highlight that the software-defined virtual antenna solution is already an implemented and certified technology that meets carrier requirements, and that it's ready for plug-and-play integration on any PCB size or form factor. This means that as long as you follow the same design layout guidelines and bill of materials used in the Thingy 91X, you can be confident that your device will meet the TRP and DAS certification requirements of the most common network operators, regardless of your device PCB size. So, having reviewed the results, just let's do a quick recap of what we have discussed so far about everything from the Nordic side and then from the Ignion side. If you want to start, Martin.
Yep. So quickly, from our side, we have gone through that what the Nordic Thingy 91X is, what it does, and what you have of support. We have full SDK support to make your applications. We also provide all the tools that you need to test out the device and tinker with it. We also provide the hardware design files on our webpage, so you can download, copy paste everything, and put your stamp on it and ship it out to customers, or configure it as you like. We also have the sample code for reference and how to change the antenna parameters listed on our documentation page. And then you, Pina.
Thanks, Martin. So from the Ignion side, we saw how enables compact designs that still deliver excellent performance even in devices smaller than 80 millimeters. We also explained how virtual antenna simplifies and scales the RF design process, helping designers to accelerate the time to market while ensuring high quality connectivity. We discussed that the software-defined virtual antenna solution delivers around 3 dB performance improvement in those lower frequency ranges compared to other passive antenna solutions of similar PCB size available on the market. And we highlighted how important that difference is for both communication quality and device battery life. We also saw that the flexibility of this solution when it comes to changes in PCB size, where it's simply a matter of programming the module with the right switch up lookup table with no hardware interventions. And finally, we mentioned that this solution supports frequencies up to 3 gigahertz, which means it covers the entire current cellular range up to 2.69 gigahertz, as well as any future wireless protocols that may emerge within this frequency spectrum. So I think we have covered everything in our recap. And if Martin agrees, we can now open the floor and move into the Q&A session.
Perfect. Yeah, so if you have any questions now that you have think about after this webinar, don't hesitate to just put it in the questions bar on the right-hand side, and we will try our best to answer them. First off, I would like to start with a question that actually came in before in this session. We sent out an email to you guys if you wondered about this topic, and we got some questions. So I will read up the first question. It's a little bit long, but it's towards you, Pina. It's this, according to the system level design principle, effective isolation is essential for the simultaneous operation of Bluetooth and Wi-Fi at 2.4 gigahertz. While various techniques exist to mitigate interface between these two radios, they often involve trade-offs that impact throughput performance for both Bluetooth and Wi-Fi. Therefore, I would like to understand what constitutes a reasonable level of isolation, as well as the maximum achievable isolation when designing Bluetooth and Wi-Fi antennas on the same PCB, specifically one that is 200 millimeter of length. So, well, as I mentioned earlier at the very beginning of the presentation, this is one of the main challenges designers face today, the isolation between antennas. In the end, there are two main actions we can take to control antenna coupling. The first one is the antenna placement. Try to position the antennas as far apart as possible from each other. In case the device design doesn't allow that, for that kind of spacing,
Then the second option is to use filters. This will mean to add extra components to the antenna matching network to filter out the frequency bands we don't want. However, we need to keep in mind that this approach increases the design complexity because you are adding components, and this will result in a reduction in performance. So from my point of view, one strong recommendation is to plan the RF transmission system first before starting the rest of the electric design. That way, you can control the antenna placement for the very beginning and preserve the best possible performance. Otherwise, if you do it the other way around, designing the electronics first and leaving the antenna system for the end, you might find there is no room left to properly place the antennas. In this case that you are mentioned, Martin, the PCB is quite bigger. So at the end, the recommendation is to try to allocate the antennas as far as possible, one each other, and this will keep a good isolation levels. If we want to say a number, a level of isolation, I will tell that values below -11, -10, I will say -10, -11 dBms in S21 parameters, I think we can consider this a good position to preserve the performance. No?
Perfect. And there's another question that came in before this webinar session. It's as follow: which options do I have to? No, this was not the question. This is the question. Realistically, for a team with embedded experience but new to the Nordic ecosystem, how long from unboxing the Thingy 91X to having a working prototype with sensor integration, cloud connectivity, MQTT/CoAP, and basic Edge ML, so Edge machine learning? Any success stories from similar IoT projects? So first off, you have already a out-of-box firmware that does a lot of this, so you can basically build upon that. It communicates through CoAP and sends the data through NRF Cloud to a front end, which also includes different sensors that's on board with temperature, etc. So you can basically just use that code and integrate this machine learning algorithms based on your favorite algorithms to kind of do sensor fusion if you want to combine temperature and humidity for a specific use case, etc. So it shouldn't take that long actually to get a prototype working. From 1 day to 1 week shouldn't be a problem. We also have a lot of typical Hackster, for example, has a lot of projects showcasing people using the Thingy 91X for environmental monitoring, for flood measurements. So if there's a flood, it would send an alarm, and those kinds of cool projects. So you can also gain some inspiration there. Now I think we can take a question. There has come in a lot of questions here, so I'll put the question on the screen here. How does the solution adapt to non-rectangular PCBs? So I guess you are best to answer this, Pina.
Yeah, sure. I think the software-defined virtual antenna solution is flexible enough to adapt to any form factor. So in that case, will be a matter to find the correct lookup table and just upload it in the module. So for the part of the defined software virtual antenna, it's completely ready. And yes, the response is yes.
Perfect. And there's another question here around the antenna solution. Does your solution work with the new 6 to 7 gigahertz Wi-Fi 6E band?
Okay, so yes, from Ignion we have many solutions. We have, as I mentioned at the very beginning, we have a portfolio of 7 antennas, and yes, we have the power to cover that frequency range between 6 and 7 gigahertz for Wi-Fi 6E that you are mentioning. In fact, if you take a look in our website, you will see a lot of information, application notes, etc., that are representing, are showing solutions that we have for this frequency range.
Good. Then there is another question that's thanks for the presentation. I may have missed this part, but are we able to see antenna performance in different PCB sizes and shapes, S-param, gain, antenna efficiency?
Yes, the response is yes. We have released 2 weeks ago, more or less, 3 weeks ago, the Thingy 91X reference design application note, and we didn't include this information there, but we are preparing now another design guide in that sense, where we are going to cover these results in terms of changing PCB dimensions, even material impact, and we are going to show there even other information, as you are saying, like gains, radiation patterns, etc. So keep an eye on the news on LinkedIn. We are posting there the news that we are doing. So because we are gonna release it very soon.
Good. Looking forward for that. And there's a question here also. Are SAW filters in use in the antenna chain in Thingy 91X when using the software-defined virtual antenna?
The SAW filters. I don't know what you are referring to. SAW filters.
So T, if you can do a follow-up there, then we can look at it after the webinar. And then there's also another question here. I'm not sure if you can answer it, but I will try, Pina. I noticed that the NRF9151 is used in the Thingy 91X. Does the same layout with the antennas and switch work for NRF9161?
Exactly. Basically, both designs, if I remember well, are practically the same. I think there is a change in the. I mean, the pads I think are a little bit smaller. I don't remember honestly. If we have the email of this person, we can
we can follow up there
offline. Yes. I will check it because now I don't have it in mind, honestly. So I will check it and I will get back to you with an email offline.
Awesome. And here's a question: can you share the TRP and TIS measurements for Thingy 91X on the Cat M1 bands?
You can find in our last release of the application note for the Thingy 91X. In the section of the measurements, you will find there TRP and TIS, all the TRP and TIS values that we measured for the Thingy 91. So take it a look because you will find it there.
Awesome. And here's also a question for you, Pina. Is it possible to cover LoRa 868 megahertz, LTM, NB-IoT, and GNSS with one antenna? For example, the Trio M Extend.
Exactly, yes, it is possible. In fact, we have a solution that covers these two frequency ranges in just one antenna. In fact, the Trio M Extend. We have it. We have documentation related to this in our website. I don't know if you can. I mean, I can send you the link. Then you can go through it and take it a look. Can we have the emails of this? The people is asking. Yeah.
Yeah.
So count that we are gonna contact you I will send you the link. You will be able to check it out.
Awesome. Yeah, there's a lot of questions. I'm not sure if we have time to answer all of them, so I just pick some on before we run out of time. Could this antenna support NTN satellite communication?
Yes, cool. This antenna is prepared to cover it. Yes, the response is yes.
Awesome. And on the same topic, I guess this I can answer. Will satellite NTN work with the existing Thingy:91X RF system? So they more or less, yes, it would work, as Pina said. The difference is that you would need a updated version of the Nerf 9151. So we have a updated version that we launched or updated this summer. So if you have that version on your design, then you should be able to run NTN. But that also requires, of course, the NTN firmware on the modem side. And here is a question on is antenna efficiency the ratio between EIRP and the power you feed into the antenna?
When we talk about antenna efficiency, we are talking about the efficiency that is the system, how efficient is the system, considering the losses between the point where you feed the signal and the power that the antenna radiates into the space. So this antenna efficiency includes the losses that are in the middle of this way, basically. The real efficiency of the antenna.
Awesome. Then there's this question. I think this is a quote from this presentation. Keep 1 millimeter between the Corvo chip and the ground plane. And this person is asking, what if your PCB is not that thick?
Well, the point here should be that we should find the correct lookup table, basically.
Good. And here's, I think this will be the last question before we move on. Hi, this might be a slightly unrelated question, but I was wondering if there's any solution for including an external antenna on the nRF9151DK. It should be possible, but there don't seem to be any connectors that can connect to the board. So on a DK, you have these micro FL connectors. So if you want to connect an external antenna on the DK, then you can use that. But follow on our web pages. There may be coming some other solutions in the future that can help you out with this as well. A little teaser what's coming in the future. So yeah, I think we can move on to you, Pina, if you have some closing words that you want.
Yeah, sure. Just mention that you may sign up for free to our Virtual Antenna Academy. This is a comprehensive course that will help you understand better our virtual antenna solution. We also encourage you to check out Oxion, our AI-powered antenna integration platform at oxion.ai. You may also check out the resources section of our website, ignion.io, for more useful information. We have, as I said, a new design about how we integrated our virtual antenna technology in the Thingy 91X. And that's all. Martin, thank you very much to everyone. Thank you to you, Martin. I don't know if you want to conclude.
Yeah, so thank you everyone for joining this webinar, and We will put out the slides as well as the recording of this webinar on webinars.nordicsemi.com. And if you have any questions related to Nordic, ask them on DevZone, and we will try to also take the questions that we didn't have time to answer on this webinar. So have a very good day, and see you next time. Thank you, Pina.
Thank you. Bye-bye. Thank you, Martin.